Welcome back. This is lesson 7 of Machine Learning Zoomcamp session 11. And in this video, we will talk about deploying with KServe on EKS. For that, we will create an EKS cluster on AWS and deploy everything we did so far in the previous lessons we deploy on AWS with EKS. To remind you, this is what we came up with in the previous lessons. This is our clothes classification inference service. In this service, we have two parts. We have the predictor, the actual model, and we have transformer. This is the component that prepares the data and also does post-processing of the output of the model. So we want to take that and we want to deploy it to AWS to EKS. And for that, we will need to change a few things. So first of all, we'll need to change that. So storage URI will be not this, but allocation in S3. That potentially we can replace with an image in ECR. We will not do this because this works just fine for us. And in principle, we know how to deploy images to ECR. We did this in the previous session. So if you ever need to do something like that, you can just go to the previous session and see how to do that. We will not cover that in this lesson. So we will take care of that part. And of course, installing KServe on EKS is actually not as straightforward as it should. So we'll spend some time doing that. So that's the plan. And for that, I actually have a tutorial that I wrote 1 year ago. Let me open it. So for that, I go to my GitHub profile and look for Kubeflow deep learning. So this is something that I created, though not 1 year ago, 11 months ago. Back then, it was KServing, not KServe. It was a little bit different. So I spent a bit of time a week ago updating this tutorial to the latest version of KServe. And in this tutorial, so this tutorial is more like end-to-end deployment of this clothing classification model to EKS. We already covered most of this tutorial, but locally without using EKS. But what we need from this tutorial is the part where we need to install KServe on EKS. So let me open this guide. Now let's follow this to install KServe on AWS. For that, we will need to create an EKS cluster. So I will just copy that. It's the same configuration as we used last time. I think I'm not sure exactly, but yeah, we will create a cluster with 2 nodes of this instance type. So let me create a folder here. I'll call this folder EKS. And then in this folder, I will create this cluster.yaml. And I will put this file here. We already have kubectl, we already have EKSCTL that we installed in the previous session. So now what I will do is I will just go and apply this config. So I'm in this directory. So I need to go now to EKS and I have this cluster. Actually, before I apply, I still have kind running here, which might be taking some resources. So what I want to do is first, I want to delete the cluster we used previously for local deployment, and then we will do the rest of the stuff. I think it's kind delete cluster. Yeah, that should be sufficient for getting rid of all the things we deployed in the previous lessons. Let me clean the terminal. So now we have this cluster YAML. Let me see how we actually apply it. Yeah, so this is how we apply it. So EKS create cluster and then this thing. And now you remember it actually takes a bit of time to do that. So while it's creating an EKS cluster, we can do other things. So this is the next thing. So configuring a subdomain. In the previous videos, when we created inference services, the URLs were like clothes.default.example.com, and we don't own this domain. Somebody else owns this domain, example.com. So we actually need to replace this example with something we own. We actually don't have to have a domain name. We can do the same like this -h we did with curl and with requests. We set header host and then wrote this URL here. And Istio used this information to forward the request to a particular inference server. So we can do that as well here if we don't have a domain name, and then we can safely skip that part. I do have a domain. So I have a domain which is called MLBookcamp, and I want to use that domain for configuring KServe. KServe will use this domain, and then the address will look something like clothes.default.kubeflow.mlbookcamp.com. Probably it should be KServe now, but I don't want to redo this thing. So I will keep it as Kubeflow. So this is something I will not do right now. This you can just follow this instruction and do that for your domain. So it explains what exactly you need to do, how you need to configure it to be able to register your domain if you didn't buy this with AWS with Route 53. So if you didn't buy your domain with AWS with Route 53, you can just follow these instructions and do that. And also create a certificate manager. This is for us to be able to use HTTPS instead of HTTP. So this is important if we want to deploy this real-life settings. So our requests should be encrypted. So we will use that. And again, I will not do this here because I already have done this just to save a bit of time, but you can follow these instructions as well. Let me check if, yeah, it is still creating the cluster. So actually we need to do that part when we already have a cluster. But there is a bunch of things we can do in parallel. Well, first of all, I think I need to clone this repo. So let me do that. So yeah, I'll just use HTTP, I guess, in a different terminal. So if I go to this EKS, then I'll do git clone. Now let me cd there. And I will need to go to this install folder. This is what we will use for installing KServe on EKS. And while it is still setting up the cluster, there are other things we can do. So we'll use S3 for storing our models, and then KServe will go to S3 bucket and get our models from there. So let us now, while the cluster is being created, let us create an S3 bucket. There should be, we already have a model. So we already did. So what I want to do is I want to create a bucket and upload the model in that bucket. So let me copy this instruction and I will change it slightly. So the bucket name should be unique. So this bucket already exists because I already have it. So it should be something unique. I will call it Alexei ML Zoomcamp models. And then you can put your name or something. And remember, the name should be unique globally. If somebody already has this bucket, now I will run this command. I will create a bucket with this name. If you try to create a bucket with the same name, you will not be able to do this. So you need to come up with a name that is unique. You can just, if you have problems, you can just put some gibberish here at the end and then, or I don't know, 001, something like this. So then your name will be unique. So let me execute that. So we created a bucket. I have bucket right now. If I do AWS S3 ls, then I will see the buckets that I have, and this is the bucket I just created. So I can list everything that is here in this bucket. Should be empty. Of course, yeah, there is nothing. So now I want to put the model we have in this bucket. Actually, I don't have the model here. Let me go a few levels up. So the bucket is in this clothes directory. Yeah, so we have this clothing model and we need to execute that. Yeah, and make sure that we have this 001 at the end. It can be just 1, it can be 0001, doesn't matter. But it's important that we have here this thing. So this is the version because it uses TensorFlow serving. TensorFlow serving expects a version there. So we have to put a version there. Let us execute that. So what this command will do is it will put the content of this folder to this location. And because this is a folder, we need to specify recursive. So it applies this command recursively and then uploads every file in this directory to this location. So we will not upload a zip archive there. We will upload the folder itself. And that should work fine for a model stored in S3. So let us upload that. So it was quite fast. Actually, I didn't need to upload this thing. So this zip archive, let me now remove that. AWS S3 aram this. No, I don't have that. So the model is there. Let me check if cluster is still. Yeah, so now I don't think I can do anything else in parallel. So I just have to wait till it finishes installing the cluster. Okay, the cluster is ready. Let's test if kubectl is configured properly as well. It seems it is, so we can access both the nodes. We configured our cluster to have 2 nodes. So now let's go to this Kubeflow deep learning and install folder and see what else we need to do here. So we need to go to install and rename this Istio operator template to Istio operator. So let me rename that. Later, we will also need to rename this thing. So let me also do this. And now I need to open this Istio operator and edit one line there. I'll use Visual Studio Code for that. It's a bit simpler. So install Istio operator. and I need to modify this line number 19. So I need to install certificate IRN here, and certificate IRN, this is something that we create here. So this is the instruction of how to create a certificate manager. I already did it. I already have a certificate manager. So I just need to go there and get the name. So let me do that. So go to certificate manager. I have one certificate here, and I need to copy the ARN here. And now I need to place this ARN to this configuration. This way, the load balancer that we will create with Istio will be able to use HTTPS because we have a certificate for this. Here we say that we want to use HTTPS, and this is the certificate we want to use. And here there's a bunch of configuration. We don't need to know much about this. So this just sets up everything for Istio. And now I think we need to run it. So let me double check. No, I don't think we need to do anything else. So now we can just run this install script. Let me do that. So it's downloading Istio. And actually, as you see here, I also use the same old version of Istio that we use locally. For the new one, I didn't manage to make it work. First of all, it was complaining about this YAML file, this configuration. I think it didn't like that these two things have the same target port. It was complaining about something else. So I couldn't make it work with the new version of Istio. I don't know Istio that well to make sense of the error messages I was getting. I just used the old version, which works. If you know how Istio works and if you know how to configure it with a new version, please let me know. Maybe we can update this tutorial. But yeah, the older version also works, so we can just use that. It largely does the same thing as the quick install script that we used locally. Yeah, you can quickly go through this. I think it's almost the same, except we use the Istio config here, and the rest is the same. So let me see. It has installed it. So what we can do to check if it works is kubectl get namespace. There should be KServe namespace. And now let's take a look at the services running there. kubectl get services namespace KServe. So we have some controllers there. Looks like it's working. Let's do another thing. So now we need to configure our domain. So for that, we have config domain.yaml file. So let me go there. We have this config domain. And here you need to replace this thing with your own domain. I will not do this because I already have this domain. This is my domain. This is a domain I own, so I don't need to replace it. And I can just execute this file. So let me apply it. This is how we configure KServe to know which domain to use. So, yeah, it seems we need to do that as well. Let me just run it. Yeah, there is controller manager. Okay, the next step we need to do is now we created a load balancer. If I go to EC2 and I select load balancers here, this is the load balancer that we created. So you can see it here also. If we do kubectl get services, namespace would be Istio system. So one of the services is this Istio ingress gateway, which is a load balancer, and this is the URL of this load balancer. So we need to take this URL and create a record in our root 53 DNS table, saying that all requests that go to kubeflow.mlbookcamp.com, they should go to this address. So this way we will use this domain name that I have, but all the requests that I will send to this domain name will actually go to this URL, to this load balancer, to Istio. I can also get the same URL from here. So yeah, this is the DNS name. Let me copy it, and then I will go to root 53. Now it says what I need to do. So I need to create a new CNAME record. I actually already have a record. I will just need to edit this. And if you don't have this, you will need to create a CNAME record. And CNAME record is just some sort of alias. So it says that a request to this domain name should be forwarded to this address. Yeah, I have this Kubeflow bootcamp. and I need to edit this name. So this is the old name of the load balancer. So I need to edit this and replace the value, the old value with the new value. So this should be the new value. And the rest is I don't need to change. So and here this is actually the same. Now I just need to update it. And yeah, we don't need to do anything else here. So this deploy and test model, we can quickly do this. Why not? So let me just create, let me call it TF flowers. So this is a simple TensorFlow model. This is the YAML file. So we just have a predictor here that goes to Google storage. We don't specify here any resource constraint. This is a relatively simple inference service definition, and let's apply it. Hope I'm in the right. Yeah, I'm not in the right directory. So let me go a few levels up. Yeah, so now I'm in the right place. Let me apply it. And it has created a service, an inference service. We can do kubectl get ISVC to get a list of inference services. And we should have something here. Let's wait till it becomes ready. And it might take a few minutes before it becomes ready. Yeah, okay, so here it is. So this is the name, and you see this is actually the name is a flower sample. Then this is our namespace default, and this is the domain. We have kubeflow.mlbookcamp.com. Let's quickly check if pods are running. kubectl get pod. So the pod is running. We can test it, and this is how we test it. We sent a request to this address, to this domain, and the addresses and the model name, default, domain, and then the URL follows the same pattern we saw previously. And you can note here that we don't specify host here. Istio, when we send the request to this address, it sees which host it sends the request to, and then it knows what to do with this request. It uses this flowers input JSON file. So this is the actual request. If we go to this Kubeflow deep learning, I have this flowers input here. Let me show you. So this is just an image, which is encoded in base 64. Probably the model that we just deployed knows how to decode it. I assume. I have no idea what the model is doing there actually, but let us check if it's doing something and it responds with something. Okay, these are the predictions. We were able to send a request there and it responded with something, with some predictions. Apparently it works. So our test was successful. Let us delete this inference service and deploy our own inference service there with this clothing classification model. To delete it, I'll use kubectl delete -f and this tf flowers. Actually, we don't need this tf flowers file here because we have it in Kubeflow. So let me remove it as well. The next thing we will do is we will deploy our clothing classification model. And for that, we need to let KServe know how to access our S3 bucket. And for that, we will need to use credentials. This is something that you can get in AWS console. You can create a user there and you can get credentials. You need to have credentials. I don't know if you can do it with a role, with ARN. So right now on this computer, I don't use any credentials. So this terminal is running on EC2 and this instance has a role. And with this role, I can do many things. But unfortunately, I do not know how to let KServe assume a role. So the way it works, you need to get these credentials, you need to use these credentials and put them in configuration. So this is the configuration file. Let me open it. The configuration file that we created in this install folder is this KServe S3 secret. And we need to run this command. This command will take your access key and secret key and apply base 64 encoding. And then you will need to go to this template and replace this thing and this thing with the encoded key and secret. I will stop recording now. I don't want you to see the keys. Okay, I just modified this file. So I put my key here, I put my secret here, and now I will apply this configuration. I'll go again to this Kubeflow deep learning folder, then install, and then this is the file where I already put the key and the secret. So now I will just execute it. So now for our inference services, we will be able to use S3, and we need to add this line here. We need to say that service account name is SA, and what it means in this service account, this SA, this is the name, it will go to my secret and it will use this secret here. I think these names are not very creative. To be honest, I just copied them from the official documentation. Probably if you're doing this for real life projects, you should change the names. So it's not like SA and my secret. Try to make them more informative, like the name of the user who this key belongs to, for example. I will not do that right now. You can, of course, try that. Actually, this bucket is not public. So if you try to do this thing, it will not work. So you will need to download the flowers model from Google Storage and put it to your own S3 bucket if you want to do that. Let's skip that and let's actually jump to the interesting part of deploying our clothing classification model. So we already prepared the model. We already uploaded the model, and now let us deploy this. We do not need to do this. This will deploy only the predictor without the transformer. So what we should do is just take the code we have here. So let me copy this and let me put it here to EKS. I will name it service, clothes service. We do not need to change the transformer, but we need to change the predictor. So for the predictor, we need to replace, so first of all, we need to specify the service account name. So we'll do it here before saying that it's a TensorFlow model. And we need to replace that with the path. And the path is, this is the path. This is where we uploaded our model. Actually, I just realized that I wanted to upload this to a different S3 bucket. So it will be my name, ML Zoomcamp models, then clothing model, and 0001. Yeah, let me again remove that thing. Okay, so the model now is here. This is the location we will use here. So I don't think we need a slash at the end. So here we do not have a slash at the end. Let's not put it. That's probably all we need to replace here. So let's test it. We'll go a few levels up again. And here we have this clothes service. Now let me do kubectl apply -f clothes service. Let's check it. kubectl get svc. Okay, it will take some time. It needs to download the model and do other things. Let me try one more time. Yeah, still not ready. It might take up to 2 minutes. So while we are waiting for the model for the service to be ready, let me take another thing. So this test transformer, and also copy it here in this EKS directory and change it. We will not need this host, and we will only need this actual domain. So I will remove the host thing. Let me remove the header, and I will need to replace this thing with the actual domain. Still not ready. It should be ready by now. Let me do kubectl get pod to see maybe something is wrong there. And let me check logs. Need to say that it's KServe container. I have a typo. So I think there is an error here. So let me see. It wants to have the saved model PB file, but it cannot find it. Let me go to S3 and check if this file is actually there. Okay, yeah, for some reasons, the problem with that is because we already have one there, the path becomes clothing model 0001, then one, and then the actual model. So I need to re-upload that. What I will do is I will upload the folder one to this location 0001. Yeah, so now everything is fine. So let me delete it. Curious to know if the model actually picked this up, if it saw that there is something new or not. Not, it didn't. Probably it will, when it restarts, it will do that. Let me kill the pod and it will start a new pod, and the new pod will not have problems. So I'll do kubectl delete pod, and then this pod. So yeah, you see that it started a new pod. So the deployment keeps track of how many pods are there. And if it sees that one pod is terminating, it immediately starts a new pod. So now this new pod is running and it's ready. So let us quickly take a look at the logs. And I don't see any problems here. It has successfully read the model from this location. And now it is entering the event loop, meaning that it is ready to accept requests. And if I do now kubectl get isvc, yeah, so I have it. And this is the URL which we need to use for sending the requests. Let me copy it and put it here. And now we replace HTTP with HTTPS because we configured the certificate manager. We can use HTTPS instead of plain HTTP. I don't think we need to change anything. So it will use this domain. Then the URL will be v1 models service name predict. Yeah, and it will send the same image twice. And then it will return the scores for these images, for these two images, and which is the same image. So the scores should be the same. Now let me test it. So I'll run test transformer and we get the predictions. So it means that we successfully deployed this model and everything works fine. So the only problem we had is with uploading the model files to S3, but we were able to fix this problem and now everything works. And I think that's all we wanted to cover. So let me check the plan. In this lesson, we created an EKS cluster. We installed KServe on this cluster. We didn't configure the domain, but you know how to configure it. Then we set up S3 access, and then we deployed the model. So this is what we did. Now our model is deployed, and we can send a request to this model and get back the predictions. So that's all I wanted to cover. Now, before we wrap up, let me stop the cluster. And for that, I will just go here and see. Yeah, so here it's a discussion of transformers. We already talked about that. So I just need to execute this command here. It is deleting the cluster. And that's all I wanted to cover in this lesson. And this is the last lesson of this session. And in the next video, I'll just do a quick summary. So see you soon.